We spend our days writing code, right? Telling computers exactly what to do, step by step by step. But what if there's a totally different way to think about programming itself?
Think about it like this. Most of the time, we write code that's like a recipe. Do this, then do that, then go change this other thing. It's just a big list of instructions. But in math, you don't really do that. A function like f of x equals x plus 5, well, it doesn't tell you how to add 5. It just describes the relationship. And that is the huge idea we're going to unpack today.
And that's where functional programming comes in. It's this whole approach that treats programs like they're just a bunch of mathematical functions being evaluated. But the real secret sauce is in that second part, avoiding changing state and mutable data. Instead of variables that can change whenever, we focus on values that are constant. And that leads to code that's way more predictable and a heck of a lot easier to test.
So here's our game plan for this explainer. We're going to start by getting into that functional mindset. Then we'll meet our tool for today, F#. We'll break down its key parts, see it in action, check out its awesome data structures, and then, at the end, figure out where it might fit into your coding life.
First things first, let's get our heads wrapped around this functional way of thinking. This really means we're going to shift from thinking about a sequence of commands to thinking about a flow of data. Imagine an assembly line, right? Data comes in one end, goes through a series of stations, those are our functions, and a finished product comes out the other side. And the key is, the original material was never changed along the way. That's functional thinking in a nutshell.
So, what's the best tool for exploring this functional world? Well, we're going to be looking at F#. It was literally built from the ground up to make this way of programming feel completely natural. F# has a pretty cool backstory. It came out of Microsoft research way back in 2005. Its DNA comes from a really powerful academic language called OCaml. And because it's part of the .NET family, it runs on the same engine as C# and gets to use all those libraries. But what really makes it special are things like type inference, where the compiler is smart enough to figure out your data types for you, and this incredibly powerful feature called pattern matching. It's a game changer for handling complex logic. Okay, let's get into the nitty-gritty, the actual building blocks of the code. And we're going to start with the most fundamental idea in F#. And it might feel a little weird at first if you're coming from other languages.
The single most important word to get in F# is immutable. See, in a lot of languages, when you say x equals 10, you're putting the number 10 into a box named x that you can change later. But in F#, let x equals 10 is different. Think of it like you're carving it in stone. You're permanently binding the name x to the value 10. From now on, x is 10, period. It can't be changed.
And here's why that's so powerful. If you even try to change x, the compiler just stops you dead in your tracks. Now, this isn't a limitation. It's an amazing safety feature. It completely wipes out an entire category of bugs. You know those bugs where you spend hours hunting down, where did this value get changed? Gone. The compiler makes your code predictable from the very start. Now, of course, F# has all the basic data types you'd expect. Integers, floats, strings, and booleans for true or false. And like I said, because of that awesome type inference, you usually don't even have to tell the compiler what type you're using. It just knows. Okay, so we have the building blocks. Now let's see how they all click together to actually create some logic and manage how data flows through our program. We've all seen a logic flowchart like this a million times. If something's true, go this way. If it's false, go that way. But look how clean the F# code is. Notice that the if-else block is an expression. That means it directly returns a value. So you can just assign the results straight to a name, all in one super readable line. Okay, now for one of F#'s most iconic, most loved features, the pipeline operator. It just looks like a little pipe symbol, but it completely changes how you read and write code. It lets you chain functions together, creating this beautiful, easy-to-read flow of data from left to right. So here's how it works. We start with a value, let's say 10. Then we just pipe it into a function called add1. The result of that, 11, automatically becomes the input for the next function in line, multiply by 5. And out comes the final result, 55. This makes really complex operations incredibly simple to follow.
All right, let's talk about how we group our data. Because F# doesn't just deal with simple little values. It absolutely shines when you start modeling complex information.
F# gives you a couple of great ways to bundle related data together. A tuple is perfect for a quick, simple grouping. But a record? A record is where you get real clarity. By giving each piece of data a name, like name and ID, your code basically documents itself. It's so much easier to understand what's going on.
And that whole idea of immutability we talked about, it applies to collections too. A list in F# can't be changed. So when you filter a list, you aren't actually removing items from the original. Nope. You're creating a brand new list that only has the items you want, like finding all the even numbers here. The original data is always safe and sound. And now, for what is basically F# superpower, discriminated unions. It sounds kind of complicated, right? But all it means is you can create a type that can be one of several different things. So here, we're saying a shape can either be a circle, which just needs a radius, or it can be a square, which needs a side length. This lets you model the real world with incredible safety and clarity. It's amazing.
So with all these cool features, you're probably wondering, where do people actually use this stuff? Let's connect the dots and see where F#'s unique powers really shine.
Well, when you think about it, it makes perfect sense. Given its mathematical roots and its focus on being correct, it's no surprise that F# is huge in areas like finance, scientific computing, and data analysis. And its powerful type system makes it a fantastic tool for really gnarly problems like building compilers or doing AI research.
This quote absolutely nails one of the biggest benefits. Functional code is often incredibly concise, but it's not just about typing less. It's about reducing the amount of stuff you have to hold in your brain at one time. When you can express a complex idea in just a few clear lines, your programs become so much easier to think about and maintain.
So we've seen how thinking in functions and embracing immutability can lead to code that's safer, more predictable, and honestly, really expressive. It's a different way of thinking, for sure, but it's a super powerful one. So the only question left is, when are you going to let functions do the heavy lifting for you?